So let's continue with the English version of the contest. We'll hear 3 more speakers now. The first speaker will be Elham Kheradmand Nezhad, and whose title is Three-Dimensional Simulation of Liquefaction Phenomenon in Granular Materials. Her research advisor is Serge Prudhomme, and her specialty mathematics.
Yes. Hello, everyone. Hello, everyone. My name is Elham. I am a PhD student in mathematics, and I have a question for you. Have you ever seen the whole building collapse after the earthquake, or the big hole is created after earthquake like the one happened in Quebec, 1971? And for sure, you're wondering what's the reason behind that. All of these damages is because of the phenomenon called liquefaction. What is liquefaction? In liquefaction, water-saturated soil loses its stability, and the underground soil is turned to liquid. So the ground loses the stability, and all of these damages happen. Why this is important for us? Hydro-Quebec has a lot of dams around the Quebec, and they're concerned about this phenomenon, and because this is the big threat for them. So the object of our research is simulation of liquefaction. What do? First, we gather the different sample of the grains around the dams. We scan each of the grain. We simulate each of the grain with one ellipsoid, which has the same volume, same moment of inertia, and the same center of mass. Now we want to gain the mechanical behavior of all of the grains. So we use the method called discrete element method. In discrete element method, first we initialize the particles. We check the existence of the contact, and if there is a contact, we calculate the forces, torques, and then by using the Newton's second law, we update the velocity and the positions of the particles. We tested our simulation with 3 particles are falling over one ellipsoid. We check the balance of the energy. We check the compressibility conditions of the fluid when we have the fluid around particles. We got very reasonable results. Now we are ready to do our simulation in a large scale. And when we have the ellipsoid, which are a very suitable representative of the real grains, we are confident that we can predict liquefaction, and we assess the safety of the dams. Thank you.